If you don't like build videos that have a voiceover, I got some bad news for you, because I'm switching it up for this one. I'm going to actually explain what I'm doing for a change, because I want to show you how you can build this cargo bike. This type of cargo bike is called a long john. It can carry a lot of different things, up to around 100 kilograms in weight. It fits some fairly large objects, and you can even use it to ride around people or your dog. It's strong, it's reasonably fast, it's easy and fun to ride, and making your own is actually not that expensive. I only spent about 300 bucks on this build. If you want to make your own, I also made some plans for this, and I'll talk a bit more about that in a minute. Before we get into the build, I want to give you a little backstory. This is the first cargo bike I ever built. This was about 5 years ago, way before I was making videos, and back then I didn't have a workshop, and this was the first time I ever did any kind of welding. I only had a few basic tools, and despite my limitations, I built this entire bike on my kitchen table in my apartment. I used a really shitty welder and I didn't know what I was doing, but I was still able to build a bike that worked great for years. I'm not saying it's a good idea to weld in your kitchen, but I just don't want anyone to be discouraged from trying this kind of stuff because you're under the illusion that you need insanely expensive tools or some kind of professional training. In this video I will be using some fancy tools because it's faster and I'm lazy, but that doesn't mean you need this stuff to make a bike. The most important thing you need to make stuff is motivation, and you can't buy that. Okay, enough with the speeches. Let's do a quick overview of the bike. This is a 26-inch wheel in the back, 20-inch in the front. For the back of the frame we are going to cut up and repurpose a donor frame from a mountain bike. Then there's the big Downtube made from square tubing and 2 steering tubes. There's a cargo bay which goes around the frame, and a kickstand at the bottom. And we will also build this steering linkage which connects the handlebars to the fork. It's not as complicated as it looks. To get started, the most important thing you need is a 26-inch donor bike with a steel frame. I bought this one used for about 50 bucks, which is a pretty good deal. And generally the best thing to use for this is a mountain bike. And then you need a 20-inch fork and a 20-inch wheel for the front. And a bunch of steel tubing for the frame. You also need some small parts like screws and nuts and a ball joint. And this was not a complete list, it's just what I had to buy, but I did include a detailed list of materials with the plans. Here are some tips on how to select a bike for this. I look specifically for 90s mountain bikes with a steel frame because the frames are pretty robust, and if you take your time you can find a used one for a pretty good price. But you want to make sure it's a decent bike and not some crappy hardware store bike. So it makes sense to look for a name brand. While I'm taking this bike apart, I want to take a second to talk about my sponsors. Of course I'm kidding because I don't have any sponsors, but let's talk about plans. I made a pretty elaborate set of plans for this build that includes a ton of technical drawings with all the measurements you need. There are also material and parts lists, as well as a lot of information on frame geometry, frame jigs, how to pick a donor bike, what parts to use, what tools you can use, and a lot more. And they also include the 3D model of the bike for different applications. You can buy the plans for this project and also some of my older projects by clicking the link up here or checking the description, and it goes a long way to support this kind of content because it's a ton of work. And speaking of support, I also made a Patreon account, so if you want you can now pitch in that way as well. My shameless self-promotion is now finished and we can get back to the build. If you want to build this bike, it would help you out a lot to have a frame jig. You can get away without one, but it's going to save you some time and some headaches, and it's not that hard to make. It's basically just a long, straight piece of material with 2 mounting points for dummy axles. And the point of the jig is to provide a fixed position for your donor frame and your fork, so you have the base for your frame geometry. You only need to set up two things, which is the height of your axles, that's the radius of your wheel, so your rims, and also the wheelbase, so the space in between them. The most important part of the jig is that your axles are as parallel as you can get them and also set up in a straight line. There's a lot of different ways of doing this, but if you only want to build one bike, you don't need to get super crazy with it. And I'm going to show you a super simple version of this jig that I mocked up just for this video. This is just some random square tubing that I clamped together, and the vertical pieces just have holes drilled in them at 90 degrees with dummy axles made from all thread and a bunch of nuts as spacers. This improvised jig is not going to be very accurate, but for a one-time build it would probably be good enough. And when you're done, you can just take it apart and use the tubing. And the white string here is just a trick you can use to check if everything is sort of straight. Here's the jig I'm using. Basically the same thing. It just looks a little different. It's made from aluminum extrusion, but it does exactly the same thing. The first thing I do is cut up the donor frame. I'm removing the head tube and the down tube. I'm using a bandsaw, but this can also be done by hand or using a grinder. Just be careful not to cut into any of the tubes you want to keep. Then I clean up the remains of the down tube from the bottom bracket area of the frame. You want to be careful when you do this because the tubes are very thin and you don't want to remove more material than you need to. Now it's time to do the miter cut, where our donor frame will accept the new head tube. I have a very fancy setup here with the milling machine, but this can also be done with a simple hand file or an angle grinder or with drill press or a bunch of other methods. This is the main tube of the bike. This is 60 by 60 millimeters with 1.5 millimeter walls. And next I'm doing the first miter cut on this down tube. There's only two of these cuts, and on my first bike I got some pretty good results doing this with a hand-operated miter saw. And now I'm cutting the end piece to length. And it's already taking shape here. And the next thing is to drill the miter for the bottom bracket. I'm using a hole saw with the bottom bracket diameter, and I'm just drilling straight down 90 degrees. So this could be done in a drill press. And on a tube this big, these hole saws tend to bottom out, so I'm cutting off a piece of it and then I'm doing the rest. Now it fits onto the donor frame like this. And here I'm just doing a test fit, which is a good idea, so you can be sure that your cuts are not completely off. And this is where the frame jig also helps you a lot, because you can keep coming back to that and sort of see if everything fits into position. This is the hole where the long steering tube is going to go through. And again, this is going in at 90 degrees, so no need to set up any angles. And then the same thing for the front head tube where the fork is going to be. Now I'm cutting both head tubes to length, and to keep the build simple, this is just standard mild steel tubing. It's time to do the first welds now, so I'm starting to clean up the materials, removing all the paint and mill scale from the areas that are going to be welded. There is one last diagonal cut at the bottom bracket. This is basically just for looks. I'm using a piece of aluminum extrusion here to sandwich these parts onto the table to make sure everything's flat, and then I'm doing the first tack welds. I tack the top and bottom first, and then I use a straight edge on the side to check if it's straight, and I'm doing a little bit of bending in the vise to get it right, and then I tack the sides. Same with the front piece, and if you don't have a welding table, you can also clamp a piece of tubing on each side to try and align it. Again, checking with the straight edge to see if there's any gaps. Then I tack the sides, and before I weld anything, I always put it back into the frame jig and check the overall fit. And now I start to tack the down tube to the donor frame and also tack in the head tubes. At this point I always try to put the tack welds towards the front or the back of the frame, because if you get welding distortion you want that to go towards the front or the back, because if your angles are off a little bit in that direction it's not too much of a problem, but you don't want your frame to distort sideways, because that's going to affect the handling of the bike a lot more. Now I am installing the headset into the front tube, because we're going to put the fork in, and then the fork is going to actually help us to align the head tube to the frame. The front headset also needs a clamp. You can use an entire stem, but I like to cut a piece out of a stem to make this a little bit smaller. This way it looks a lot nicer, and it should have enough power to keep everything in place. Now that the head tube is centered on the fork, we can put the fork into the frame jig, and then the head tube is aligned to the frame, hopefully. Now I'm tacking it in, and before I weld it, I'm going to remove the headset again. You generally don't want to weld near any headsets or any other bearings, because it kind of ruins them. Now with everything tacked up, I take the frame back out of the jig, and now it's ready to be welded. Once I'm done tacking, I don't weld in a particular order, but I switch up the spots I'm welding to even out the heat input as best as I can. I get a lot of questions about what welding machine I use. This process is called TIG welding, and it's generally the best thing to use for something like a bike frame, but you can make this work with almost any process like MIG or stick. For my first bike I used what's called flux core welding, which is essentially like a very dirty version of MIG, because it doesn't use gas, and I bought a very cheap machine that could only switch between 2 amperage settings, so it was just about the worst thing I could have used, and like I said, even that worked out fine in the end. The main frame is now welded, and I'm making 2 little gussets that go into the corners. And I'm using the same tubing that was left over from the frame, just cutting these triangles out of it. And then they go on like this, which is going to give the frame a lot more rigidity in the front. As the last step for the main frame, I'm welding in this cap here at the bottom bracket to close the hole. And these are some of the few welds I decided to grind down because it looks nicer in this area. Now the main frame is all welded up, except for this hole here, which we're going to close later. Next we're going to do the cargo bay. There's a bunch of straight miter cuts to do and 2 tube miters. And again, this can just be done with a file or with an angle grinder. And that's what all the pieces look like. It's a lot of work to cut these, but it's actually not that complicated. I start by tacking up the large side pieces first. And then I use a lot of clamps and straight pieces to clamp this onto the frame. You can use any kind of straight tubing you have to align this. And the goal is to get the sides in one flat plane with the middle of the frame. I'm not going for high precision here. If it looks flat, it is flat. If it's all in a good position, I start to tack weld these onto the main frame. And now I'm starting to do the smaller side pieces, and I'm again pre-assembling these on the welding table, and that makes it much easier to actually put them on the frame. Like I said, it looks pretty complicated with all these angles, but once you start breaking it down into pieces, it's actually pretty simple. This is where those 2 round miter cuts come into play. They attach to the steering tube. Everything is now tacked up and in position, and I can remove all the clamps, and this is what the frame looks like now. There's a lot of welding to do at this point. This probably took longer than welding up the Downtube because there's so many little joints to do. But I don't want to bore you with endless welding shots, so this part is now pretty much finished. And we can go on to the next part, which is to build all the parts for the steering linkage. This is how the steering works. And the first part we're going to build is this long steering shaft. This is basically just a long tube with the steering arm at the bottom, but it's not quite that simple because it needs to have exactly the right size to fit a headset at the bottom and to mount a stem at the top. And the easiest way to achieve that without using a lathe is to just use another fork and modify it to become a steering shaft. This is a cheap fork that I don't need anymore, so that's what I'm using, and I'm cutting off the legs for the first step. Then I clean up the remains until I'm left with this little stump, and then I cut off the bottom of that. And now what we can do is to use another tube to extend this and make it long enough to go all the way through our steering tube. And I'm setting these down in a piece of angle iron to align all the pieces in a straight line, and then I tack them together. The steering arm that goes on the bottom is basically just a piece of flat bar with some holes in it. That gets welded to the bottom of the shaft. And now we have a steering shaft where you can fit a headset crown race at the bottom and also put a stem at the top. And by the way, you can make this thing as long or as short as you want to, depending on the size of your frame and also how high you want to have your handlebars. And to be honest, I only built this thing to show you because I used a different approach. I built a second shaft using aluminum and doing some machining, just because I wanted to save a little bit of weight on my build. The end result of what I'm doing here is pretty much the same. It's just a little bit lighter, a little bit longer, and it's a slightly different way of doing it, but you get the idea. And once it's done, it's installed just like a normal fork, basically. You just put it in the bottom, push it all the way up. Then you put the stem on top. And later on I'm going to put some spacers underneath so the stem is in the right position. But you can now see, if you turn at the top, then the steering arm moves at the bottom. Now I'm making the steering rod that connects to the fork. This needs to have a bend in it, so it can go around the front wheel when you're turning left. And ideally you would bend this, but since I don't have a metal bender, I'm cutting 2 miters and this little connecting piece, and then I just weld everything together to create the bend. And the reason I'm doing 2 miters instead of 1 is just so the shape is a bit more round, so there's not a sharp outside edge. Here's a little trick. I'm using citric acid to remove the zinc coating from these coupling nuts, which makes them much easier to weld later on, especially when you're TIG welding. We are going to modify these nuts to become bearings for our steering linkage. They are M10 nuts and I'm drilling them out with a 10mm drill, so I'm just removing the threads. And now we can put a bolt in there and it can rotate, and that's going to be our bearing. I'm putting 2 notches into this little piece of tubing, and that's going to connect our 2 bearings to each other, and one of them is going to be rotated 90 degrees because we want to create a 2-axis joint. Now I am taking 2 more of these coupling nuts. These ones have their threads intact, and I'm just slightly turning down the outside edge so we can put this inside the end of the steering rod. And again, ignore the lathe, I'm just lazy and I could have used a file. There's just one more small part we have to make for the steering now, which is this little bracket, which has a piece of all thread attached to it. Now we are ready to assemble the steering linkage. For the final assembly, there's going to be a bunch of grease in there, but right now I'm just doing a dry fit to see if everything works. I'm using plastic washers because they have less friction, and on the bottom I use a lock nut, which makes it possible to set the tension for this joint. And you want to screw it in until you don't have any more play in the joint, but it should still move relatively smoothly. Now that bracket comes into play, this connects the steering rod to the 2-axis joint, and it's possible to screw this in or out of the rod to adjust the length and fine-tune the overall fit. And again, there's a plastic washer in there and a lock nut on the other side. Same thing, you want to set the joint so it's not too loose, but also not too tight. This little bracket is going to be welded to the fork, and it's going to accept the other end of the steering rod. And the position for these is a bit different for every fork, so I'm kind of eyeballing this. I just did one tag there, so I can now bend it a little bit and get it into a good position. You want to put some little spacers on this bolt on both sides of the joint, and that gives the joint a little bit more room to move so it doesn't collide with the bolt itself or with the bracket. This movement here is the reason we are not using ball joints on both ends. You can do that, but then the steering rod is free to bounce up and down. But because we built a 2-axis joint, we can now tighten these nuts and lock up the steering in a horizontal position. And otherwise it would be able to bounce up and down every time you ride over a bumpy road. I did that on my first bike, and trust me, it gets super annoying, and it also makes the ball joints wear out pretty quick. So essentially this is the only reason for building that joint. Mounting some handlebars to try it out. And what do you know, it actually works. And now the steering is finished. By the way, the reason for these holes is you can switch the position of your joint and set up the steering ratio how you like it. So you can have the front wheel move more or less in relation to the handlebars, and that's completely up to personal preference. Just play around with it. Next up is the stand. You might be tempted to skip this and just install a store-bought stand in the back and call it a day, but I can assure you this bike is kind of useless without a really strong stand. I'm cutting open one side of this piece of square tubing to create this U shape. These will be the legs, and they have to be rounded over at the top so they can move. Right now they should fit into these brackets we made, and they can move 180 degrees in there, but we don't need that much. Now I am welding up the stand. I'm using aluminum here because I can, and it saves a little bit of weight, but you can use the same measurements and just use steel. It's just going to be a bit heavier. This is what the finished stand looks like, and the shape is going to make sense in a second. I'm installing the brackets on the stand, and then I use the stand itself to align everything to the frame. And when everything is in a good position, I can tag on these brackets, and then the stand can be removed. Now you can see the reason for that shape. It's to give some room to the steering to move and not collide with anything. Here's how the stand works. Now it's not staying up because we haven't installed the springs yet, but that's the basic principle. Now that I know everything works, I can weld on the brackets. And they also get this supporting piece, which makes them a little bit stronger. It's also just a piece of tubing. I'm using rivets to put some tiny brackets on the stand. You can also weld this or just put a screw in. And on the frame I tack on this nut as a holding point for the spring. Now we can install the springs, and these are going to hold the stand in both positions. It's gonna pull it up when you ride the bike, but it also keeps it in the deployed position, so when you lift the bike, the stand doesn't snap back in. It only snaps in when you push the bike forward. And that's how it works. And this stand is very strong. I'm not exactly light and I can jump around on this no problem, and the stand doesn't budge, and that's exactly what you want in a cargo bike stand. We are now on to just little details. I'm welding on a bunch of small nuts. This is completely optional. I'm going to use these to attach the cover for the cargo bay, but that can also be done by just drilling holes into the frame or any other method. Putting some nuts on the steering tube as well, and I'm going to use these as cable guides. There's nicer ways of doing this, but it works. God damn it. This cap is going to close up the hole on the front end. I drilled a hole in the middle and I'm welding a nut in there to create a mounting point to attach things to the bike. I actually don't know what I'm going to use this for. It just felt like a good idea. Here's a small thing I almost missed. On the donor frame, the C-tube wasn't welded to the bottom bracket all the way because that's where the downtube used to be. So I'm adding this weld now. I'm also adding some disc brake tabs. This is way too much to go over in this video. I actually made a custom jig just to do this. But I'm gonna link another video in the description where you can see how I did this on another bike without using a jig. I'm not actually going to use disc brakes on this bike, I'm just installing this just in case. Now we are already on to painting. And I already found a use for that bolt that I put in the front. I just do a simple rattle can paint job. These cans are from Montana Gold, and I like these because they are low pressure and it's almost impossible to make this paint drip, which is why I'm going in so close. I just do one coat of primer, paint and clear coat, nothing fancy, because it's going to get scratched up eventually anyway. This color is probably a bit controversial, but I needed something that pops in the thumbnail. The fork and the steering parts also get some paint. I didn't paint the stand because that one's aluminum, so it's not gonna rust. Here's the finished paint job, and all that's left to do now is make a cover for the cargo bay, then assemble the bike and ride it. For the cargo bay cover, I'm using this aluminum sheet because it's light and it's not going to rust. I'm using a plasma cutter to cut this to size, but this stuff is also easy to cut with a jigsaw. And you can also use a different material. Some people like to use plywood. And this also needs a bunch of cutouts so it can fit around the frame. Now I'm drilling mounting holes to screw it down. And these large holes are going to make it possible to attach holding straps or hooks to the cargo bay frame. It's finally time to assemble all the bike parts. Apart from the steering and the stand, it's just like putting together any normal bike. This time I'm putting a bunch of grease in these joints. For the stand I'm using lock nuts again, because we only need these to stay in place. No need to tighten these down, because then the stand won't move. When it comes to bike parts, you can use pretty much whatever you want, but obviously on a workhorse like this it makes sense to use reliable, sturdy components. And of course you can also install an electric motor kit like a Bafang or something and make this into an e-bike. Mid-drive or hub drive should both work, and there's a lot of space to put batteries as well. Now those nuts on the steering tube come into play. They will hold the cable housing for the front brake. And you do need an extra long brake cable for this bike. They're often sold as tandem brake cables because tandem bikes also need that extra length. At this point I have to install the cargo bag cover because the brake cable actually goes through it. The mounting point for this spring can also double as a holder for the brake cable, and I prefer to use a full brake housing without any open parts, so I don't have to bother with any cable stops. And now you can see why I put this nut up here. It's also a cable holder, and by the way, if you're using disc brakes you want to put that on the other side of the frame. I put one on both sides just in case. It makes sense to use stainless bolts to attach this cover because anything else is gonna develop rust pretty quickly. And now it's finished. As always, here comes the ending montage. Thank you for watching. I hope this video helps you to make your own bikes. Let me know in the comments if I should make more videos like this one, and also smash that like button and subscribe and all that, and see you in the next video.